Hi there and welcome. I'm TexasTim.dev, and this is my channel where I'm grinding through LeetCode. I've ground through all the easy problems, and now I'm working through the medium. Although once in a while LeetCode will publish a new easy problem, and so I get to have an easy day, but mostly it's the medium. And then once I'm through with the medium, it'll be, onto the hard. But let's see what we got today. Let's check it out. Head on over to, actually I made a bookmark. Or I did, yeah, here it is. These are all the medium that I have not done yet, sorted by acceptance. And sometimes I do just the top one, but then when I see a high frequency problem, then I think that's going to be probably a more interesting problem, maybe more relevant to more people. So why don't we look at this design hit counter? Let's see what this is about. Let's give it a go. 362, design hit counter. Design a hit counter which counts the number of hits received in the past 5 minutes. Okay. Look at that, 1,164 thumbs up and only 100 thumbs down. So this is probably supposed to be a pretty easy one. of the medium category, this is probably one of the easier ones. And looks like a lot of people got their submissions accepted. And no hints, interesting, no hints. Just have to figure it out. Let's finish reading the description. Your system should accept a timestamp parameter in seconds, and you may assume that calls are being made to the system in chronological order, i.e. timestamp is monotonically increasing. Of course, monotonically, I believe, means that it never decreases. Oh my goodness. Monotonic increasing. Yeah, it means increasing. Several hits may arrive roughly at the same time, so implement the hit counter class. Hit counter initializes the hit counter system. Void hit int timestamp records a hit that happened at timestamp. Several hits may happen at the same timestamp. Okay. Int get hits int timestamp returns the number of hits in the past 5 minutes from timestamp. Okay. So this is it's a little bit kind of like a priority queue, and we just want the most, in the sense that we want just the most recent 300 seconds. I mean, that's what occurs to me first. Initialize a hit counter. Let's look at their example. Initialize a hit counter. Give it a hit. Give it some hits. Get the hits. Oh my goodness. Well, why don't we get in there? If I can. Is that still easy to see? Yeah, probably. Okay, let's look at the constraints. Wow, that is a lot. That's the timestamp could be between 1 and 2 billion. And they mention the chronological order, and there'll be at most 300 calls. What if the number of hits per second could be huge? Does your design scale? So, thinking about ways to do it, I mean, I could have some kind of list or queue of the hits in each second. And then a real kind of naive and non-performant approach would be to just iterate that list every time there's a get hits call and add up the sum within the range. The range meaning the last 300 seconds. Right, last 300 seconds. Yep. Alternatively, instead of recalculating the sum every time, we could add hits when they come in and then check the tail of our list or queue or what have you. I guess a list would be fine. They're going to come in chronological order, so depending on if we like insert at the head, I mean, we'll insert at one end and we'll delete at the other end. And it'll be real easy to just, every time we get some hits, we'll add that to our sum. And then whenever we get a get hits call, then we'll look at the tail and prune off any hits that are out of scope, out of our 300 second range. And then as we delete those, we'll decrement our hit count. So let's think about some of the fields we're going to need. So timestamp. So when we get a hit, that's one hit, and it's for a particular timestamp. And since there's going to be no more than 300 calls to hit and get hits, that means that our number of hits will never exceed 300. Okay, so we can use an integer. Hits within last 5 minutes. Initialize. All right. Okay. So I think when we get a get hits, then we'll call some kind of prune old hits. And that'll be like a private function. And this will look at the tail, or the old end. We'll call it the new end and the old end, or more recent end and older end. And so we'll only prune when we get a get hits call. So we'll start at tail and prune off hits that are too old. So we're going to need some kind of data structure. And let me just make sure that I'm thinking a linked list. I just want to make sure I can access both ends. And I want to make sure that insertions are in O1. It's not synchronized. That's fine. I believe linked lists. Oh, if it's in the middle. Node finding. I won't ever have to do node finding. I think I can get last. Well, and interestingly, I'm going to have to store. No, no, because it's, I thought for a moment that the hit function could give me a number of hits, like, hey, in this timestamp you got 5 hits, or this timestamp you got 2 hits, in which case my data structure would have to hold not only the timestamp but also the number of hits, but each hit is only 1. So we could just have a list, and if there are a linked list can contain duplicate elements. So if we get 5 hits in a row with the same timestamp, then we'll just have 5 of the same timestamp value in a row. Okay, so hits may happen at the same timestamp. All right. So let's do list of integer. These will be the timestamps. Just want to make sure it'll fit. That's a short. I don't want a short. Int 32. Yeah, plenty of room. Plenty of room. So list integer hit, what would you call it? Hits record. Oh, maybe we'll just call it hits. And then list. All right. So when we get a hit, we are gonna add it to the front. We're gonna add first. So hits. New linked list. Add first timestamp, and then increment. So it's gonna, this value is gonna be incorrect if it gets, once we start, it could be incorrect up until, it could, the hits within the last 5 minutes could actually record hits from more than 5 minutes if we haven't yet called prune old hits, because we're only going to prune old hits when we are asked to provide the get hits. Well, that's convenient that get hits gives us a timestamp. That's nice. That means I'm going to have to provide that same timestamp that are older than 5 minutes before given timestamp. Return this. Cool. Very nice. Add. Okay. Now let's do prune old hits. So we can get last. So let's see. Int last equals hits get last. Then can I delete the last? Yeah, I can pull last. So while last is less than timestamp minus 300, then get rid of it. And then just return. I should probably notate that it's a void type, not returning anything. All right, let's look this over. Oh, we've got to subtract gonna remove last. So hit, we add a hit. Well, I guess no, no, we don't want to, because last would be a timestamp. We just want to subtract 1. There we go. So when we get a hit, we add the timestamp to the front, increment our counter. When we're asked to report the number of hits for within the last 5 minutes of this timestamp, that's when we prune old hits. And then I have to update that. What happens if there is no get last? Returns the last element. Throws a no such element exception if the list is empty. Okay, let's put in some guard clauses here. So if get hits is called and yet hits is empty, we can just return 0. And so now we know if we go into prune old hits, there's going to be at least one value. So this one is for sure. Decrement it. And then remove it and set it to the next one. But what if that is the last one? So if hits is empty, then we can just return. Otherwise, we're going to do another iteration or another, loop. If it's empty, give 0. Otherwise, prune hits and return the hits. I kind of want to run it. Oh. I was wondering why the autocomplete wasn't doing it. I think because I just put list up there. Oh, it didn't work. So close though. So we initialize a hit counter. We hit at timestamp 1. We hit at timestamp 2. We hit at timestamp 3. Right? And then get hits 300. So that would 301. Maybe it should be less than or equal to, I think is what that needs to be. That way, if the last one is 1, times 301 minus 300 would be 1. And yeah, I was, off by 1 errors will get you every time. I needed to include the minus 300 has to be one of the values that to count as being pruned off. All right, I kind of want to submit it. Let's see. Yes! Ooh, and look at that speed. That is not too bad. But you know what? I'm going to bet everybody's up there. Let's see. I'll bet everybody's up there. I want to update the memory usage. I like to keep track of how some of these algorithmic approaches perform. All right, let's look at what other people got. Yeah, look, we're all up there. Still, I'm happy to be part of the crowd. What did this person do? Similar, okay, linked list. Ooh, but a linked list of an integer array. Then total count. The list isn't empty. Huh. Timestamp 1. So they, oh, okay. So they're they're looking at the follow-up. What if the number of hits per second could be huge? Does your design scale? And so what they do is, wait, where'd it go? Oh. If they already have that timestamp, which they can just look at the peak last because it's monotonically increasing. So it's either going to be the last. If it's going to be the same one, then it'll have been the most recently added. He's adding it to the end apparently. That's why he's doing peak last. But he just then increments that value in that array. That's good. That's good. I like that. I didn't think of that. I didn't think of the follow-up. Anyway, hey, thanks for coming along with me on this medium difficulty problem. Ended up being not that hard, really. And I hope you'll join me the next time. If you want to be alerted whenever I have another video uploaded, then you can hit like and subscribe and tick the bell, and that way YouTube will make sure to let you know. Okie dokie. See you next time. Bye-bye.